Hi guys, this is going to be a quick little video on something that is called basic stoichiometry. Stoichiometry is like the center of everything that we're going to need to do as chemists. Anytime we do any kind of chemical reaction, if we're ever curious about if we start with this many grams of one substance, how many grams of the other substance do we need, that's actually stoichiometry. And what we're going to do in stoichiometry is we actually will be using the coefficients from the balanced chemical equation to relate the amounts of one chemical substance in the chemical equation to another substance. Now, you guys should have already read sections 9.1 and 9.2, so this first part is going to be a quick little review for you here. What I'm going to do is the chemical reaction I'm going to be talking about here is going to be nitrogen gas reacting with hydrogen gas, and in a synthesis reaction, that's going to produce ammonia gas. And if I balance this, I know that I'm going to need a 2 there to get my nitrogens, a 3 there. And even though we don't usually write a 1 there, I'm going to use that here just as for clarification. So this means for every 1 mole of nitrogen that I react, I need to react with it 3 moles of hydrogen. And when I do that, I will produce 2 moles of NH3. Using the coefficients in the balanced equation to relate quantities of one of the chemical substances to another. All right, so let's say I had a situation where I have 0.951 moles of hydrogen, and I want to know how many moles of ammonia can I make? Well, some of you guys might be saying none, because if all I have is hydrogen, I can't make ammonia because I need to have some nitrogen to make it as well. And so if ever we have a problem where only one reactant quantity is given, then we are going to assume we have excess or plenty of any of the other reactants. Okay, so let's go ahead and just really quickly following the format that your book showed you. So I'm going to start with 0.951 moles of hydrogen. That's my given. And I want to convert moles of hydrogen to moles of ammonia. So I'm going to go ahead and look at those coefficients from my balanced equation there. And I know for every 3 moles of hydrogen that I will make 2 moles of ammonia. So these are the coefficients from the balanced equation right here. Again, we use the coefficients from the balanced equation. Unit analysis, we know we cross our units out. And so when I do this, this tells me that I will be making 0.634 moles of ammonia if I react all of the hydrogen and I have excess of the nitrogen available. All right, 3 sig figs in this measured value, infinite sig figs in those counting numbers. So then I need 3 sig figs in the answer. Easy. All right, so one thing that we do sometimes, though, is we aren't necessarily given the number of moles of things that we have. In labs, we measure things in grams. So let's say I have 27.0 grams of hydrogen, and I want to know how many grams of ammonia can I make? Okay, so I'm still using the same equation. Nitrogen plus hydrogen is going to give me my ammonia, and I still know my molar quantities. But this doesn't mean 1 gram and 3 grams gives me 2 grams. It is molar ratios. Well, I think I can do that because I know if I have 27 grams of hydrogen, I can very easily convert this into moles of hydrogen. This is what we, just learned in our last unit. Now I get to use my coefficients from my balanced equation, and I know for every 3 moles of hydrogen, I'm going to make 2 moles of ammonia. Now, this is really important again, guys. Remember, I told you in our last unit, we need a number, we need a unit, and we need an identity of a substance. There's 3 parts to everything that we write down there because of a mole of ammonia doesn't cancel with a mole of nitrogen or anything else. So we need to make sure mole of hydrogen cancels with mole of hydrogen, grams of hydrogen with grams of hydrogen. All right, you might be thinking I'm not done, because you're right, because I didn't ask how many moles of ammonia I can make. I asked how many grams. So if I figure out what the molar mass of ammonia is, it is 17.04 grams. Now all I need to do is I need to do my math. All my units have canceled out. And what I'm going to end up with is, I didn't do that math there. I guess you guys can figure out that math. That many grams of NH3. Well, I suppose I better do this for you. So I'm going to do 27 divided by 2.02 times 2 divided by 3 times 17.04. And I need to round it to 3 sig figs. So it's actually going to be making 152 grams of ammonia. Now, sometimes I have people say, well, wait a minute. Why are you saying 1 mole of NH3 when there's clearly a coefficient of 2 in front of there? Because this is using molar mass. And by definition, remember, molar mass is mass of 1 mole. So the only time we're using the coefficients from the balanced equation is when we're relating one part of the equation to another part of the equation. So really, just what I have highlighted there, that's the only stoichiometry in this problem. All right, so basic stoichiometry, I'm given one reactant, and I use the coefficients in the chemical equation to relate moles of one to moles of another. If I'm not given moles, I'm given grams. I just need to do some molar conversions. Great. All right. So our next video, we're going to talk about, well, what if I'm given the quantities of 2 of the reactants? Let's go look at that one.